Hello, everyone. This is Prashant, and I'll be your host for the ChoubeySahab Podcast. And today we have a 15-year-old student who's working at the intersection of biomedical and computer vision space. He's also working on a research project at UHN while being a fellow at the Knowledge Society, which is one of the most amazing society working with teenagers and making them work on exciting projects. And Shiza is just one of them, and she's doing super amazing. And today I'm here to learn from a 15-year-old who's doing things much beyond her age, helping recognize tumors in humans, like solving really complex problems at a very early age. And these are some of the people that I'm really, curious about, like how are they working on such complex problems at such an early age. So Shiza is one of them right here sitting in front of me, and I'm going to interview her and try to learn as much as I can from her about how was she raised to be so good at what she does at just 15, and number two, about the things that she's working on, because these are somewhat really complex things. I will try to make her explain those to us dumb people like we are just 5 years old, right? So let's get straight into it. Shiza, tell us about your story. How did it all get started from the very beginning, from your childhood? I want to understand how you became what you are right now.
Yeah, for sure. So hi, everybody. My name is Shiza, as Prashant mentioned. So a bit about my story. I was always interested in the healthcare space. A fun fact about me, I actually wanted to be a doctor because I was just so interested in learning about different diseases, about different illnesses. And from there, I was just so interested in the healthcare space. But then grade 9 came along and I got interested in programming and building things. And I just found that area so interesting. So I had these two passions. But then I was like, well, what do I want to do in the future? And I thought to myself, why not just combine those two? So first of all, with the programming, I learned different programming languages such as Python, processing JavaScript, HTML, CSS. But the thing I found about those was that they didn't really solve some sort of real world problem. I do these problems online, but they were more about coding problems. They weren't about how to solve a disease. Stuff like that really interested me, but I didn't really see an application of programming languages and the problems that I did to make a real world impact, which is something that I really care about. So what I did was I looked deeper into technology, into real world applications, especially with healthcare, to combine those two fields. And then I came across AI. And from there, I kind of fell in love with AI, especially computer vision. So the thing about AI is there's different subsections, right? So within those different subsections, there were a lot of applications to healthcare, but the subsection that had the most applications was computer vision. So I decided to go within that first. So I learned a bit about that. I read some research papers. And then I built some projects. So classification projects of classifying different diseases, and then segmentation projects. So one of mine was segmenting the brain tumors from MRI scans. So things like that I worked on, and then I got really interested into that space. And from there, I just kept going and going to increase my knowledge and skills in that space. And now I'm working with some researchers at UHN, as you mentioned.
Yeah, that sounds great. And for a 15-year-old to say that I wanted to do something that actually has an impact and not just play around with random things, that's crazy. That's mind-blowing. I've interviewed some amazing founders. I know a lot of amazing founders. I follow a lot of amazing founders, and they're working on great problems as well. But the amount of impact it has on real world and real people, it isn't as much as maybe what you're doing, right? So people these days are more motivated by money. That is my belief, my personal belief, of course. But I believe that people are more motivated on what is going to get me more success, what is going to get me more money. But it was amazing to hear a 15-year-old say that, okay, I wanted to do something that actually has an impact on the real world. And the space that you're working on can potentially save lives. So that's the kind of impact we're talking about here. Yeah. Incredible. Kudos to that. All right. My next question is that how did you get interested in this computer vision space? Plus, what is the potential impact of this space? What are the implications, different implications of it, and the implication that you're working in right now?
Yeah. So obviously, especially in the last decade, computer vision has grown so much. I've seen that models were 50% accurate, less than a decade ago. And now they're 99% accurate, which is completely insane how much the space has grown. For me specifically, I wanted to look into healthcare, as I mentioned, because I had that passion for healthcare. But obviously, there's so many different applications of computer vision. So there's security, for example. So like in iPhones, you have the Face ID feature that uses computer vision. Things like self-driving cars is a major implication of computer vision that's emerging right now, especially with companies like Tesla. They're trying to build computer vision systems in order to, first of all, like classify the different objects in the scenery and then segment out different objects as well so that the car knows where it has to go, and just like linking all of those systems to make a self-driving car. That's also an emerging field. There's also manufacturing and retail. So I looked into Walmart in like a few months ago, and like some of the things that they wanted to do to leverage their customer base and just attract more people. So one of the things that I found was that there's computer vision being used to look at what products are defective or not. So that those are like major applications, but there's so many small ones too. Like I recently looked into declining marine population because of the fact that like the population of fish is decreasing. So what computer vision is doing is like it's finding insights within those fish. So it's trying to classify different fish and then like find out the environment they're living in and trying to solve the problem that way. So there's like major applications, there's minor applications. So obviously that's like the application side, but then more on like the model and the accuracy side, like computer vision, obviously, as I said, like has grown so much, like models have become so much more faster. They can process a lot more data. They're a lot more efficient, things like that. Like it's just growing at such a rapid pace. And then that's not only with images, like I've worked with images in basically for my last few projects, but there's also video with computer vision, and that's mostly like self-driving cars because you need to do like real-time segmentation while the car is moving. So that's more of video, but there's more potential in terms of like combining different cross sections of AI. So with computer vision, you might have something like NLP, which is natural language processing, and it basically uses like text. So if you give the computer a certain piece of text, then it can translate that into an image. So let's say you had a description, it would basically just form an image like that. And companies like OpenAI, like one of the biggest AI companies, have been working on things like that. So I just see that exponentially growing, especially with the rate it's been growing right now.
That's great. And this is the most attention I've paid ever to an answer being given to a question on my podcast, because there was so much insights in there, and all of which will be shaping our future. But we, as general people, normal people, I'd say, are not aware of these technologies much and what can be its potential impact on the future. But that's what I love about kids your age, students your age, who are interested in these spaces which are going to shape our future, but not just interested, but actually actively participating in these spaces at very early stages. And that's something that I don't see the majority people your age not doing, which is not great. In many ways, we can probably blame the school system that it doesn't get that much excitement, burning out of students to be getting deep into these spaces. But I want your inputs on this because I believe you are a school student yourself as well. So how do you contrast you being a school student and you being maybe the Knowledge Society member, right? So how are these two different? What does the school get wrong? What does the Knowledge Society get right? And which has made you what you are today, the school or the Knowledge Society? That one.
Yeah, for school, I definitely find like there's a huge difference with what I see in the Knowledge Society. In terms of school, like a lot of it's mandatory. And then because of that, it just gets repetitive. So it's not like personalized to what you want as a person, what you want to explore, especially with like the technology classes, like the computer science class I'm in, like most of it's programming languages, right? And as I mentioned, like obviously I'm passionate about programming languages, but like most of the things we're learning is like making games. So not a lot of that is like real world impact. And you're right, like a lot of teenagers right now, they're not focusing that much on impact. And then even people who are older, their incentive right now is for a lot of them is money. That's the thing I really find like about being young. Like I don't have to worry about money that much. So I can just capitalize on the time I have and make the most out of it. So for the school system, most of it's like, you need to learn the math for university. You need to do this for university. But even in the long run, like having some of the skills that TKS, the Knowledge Society, has taught me is just incredible. So a bit about the Knowledge Society, I joined like a couple of months ago. And from there, like I found that the program was so personalized in the sense like I could explore any technology that I wanted. So I was exposed to different technologies like blockchain, like Internet of Things, like nanotechnology. And then from there, obviously, I chose AI because I was really in love with it. And then I went deeper into that space. Now, that's something I usually don't see in school. Like if I wanted to focus on something for an assignment, even if I found it really interesting, it wouldn't be a long-term project. It'd just be like, okay, finish this assignment, hand it in. Now we're moving on to the next unit. Over here, like I can just dive as deep as I want into the space. There's literally no limit. So I could just keep going into AI, keep going into computer vision, and it would just be self-learning at that point. It wouldn't be some teacher telling me that I need to do this. It would just be my own interest guiding me. So like in terms of the exponential technology that I learned in TKS compared to like the education system, it's kind of archaic in that sense that it's not really sticking to the emerging technology that's disrupting our world right now. That's more on like the technology side. Obviously, like the skills also I've learned in TKS, things like content creating, giving feedback, presentations, a lot of that has helped me so much, especially growing as a person. Like I've noticed my confidence changing so much. I'm a lot more authentic and stuff like that. Like my mindset's also things like anti-fragility, going out for things, being resilient, things like that we don't really learn in school, but learning that in TKS, I can literally apply it to every field I work in. And that's the thing I find about schools, like even for making a resume, even for putting yourself out there, letting serendipity compound with social media and just like posting things, doing presentations, things like that we don't focus on school. It's mostly just getting grades. That's the incentive. But then at something like TKS, the incentive is to grow as much as you can to become the best version of yourself as you can. So those are like the major differentiations.
I got it. And it's amazing. It's amazing just how TKS functions. I've actually never been a part of TKS myself. I'm actually 22 right now, and there is probably some age criteria becoming a part of TKS, right?
Yeah.
And so I'm probably already old. I'm marked by TKS. But anyway, I never got a chance to be a part. But I've always followed a lot of fellows from TKS, and I love the kind of work they're doing. There was one person that I interviewed on one of my podcasts who was working on aerogels, which was again an insane technology. Then there was one girl, her name is Isabella Grandick, and she was working on some really amazing projects. So I'm just mind blown by so many of TKS fellows. I don't know if I can officially become a part of TKS, but TKS, I feel a part of the community, even being outside. I feel a part of TKS, and it's amazing what Navid and team are building. Brilliant stuff. All right, coming to my next question. You are working with United Health Network, right? I get that right? Yeah.
University Health Network, but close enough, yeah.
You correct me, right?
University Health Network, but yeah, that was close.
Oh,
yeah.
University Health Network. I'm so sorry. I just remember the abbreviation. Okay, got it. So University Health Network. Mm-hmm. Okay, got it right?
Yeah.
Yeah. So that's great. Tell me about that. How does the collaboration work? You go to that university and work with some researchers, professors, and what is your pursuit? What are you trying to do over there?
Okay, yeah. So UHN basically is like a research hospital in Toronto. Like it's a really big research hospital. So I think it'd also be valuable to tell you like how I actually got that role and that opportunity, because like it's actually a really interesting story. So what I do is like I put out these monthly newsletters of talking about like what I've been up to and like the things I've accomplished throughout that month. And so I put out one newsletter talking about my project, the one I mentioned in the beginning of like segmenting brain tumors from MRI scans. And then someone replied to my newsletter and they're like, well, it reached an accuracy of 93%, which is really good. So they're like, why don't you reach out to people and like medical experts and people in hospitals to see if they'd be willing to implement this, right? Because if it has such a high accuracy, like doctors probably would really benefit from it. So that's what I did. I went on LinkedIn, I searched some medical experts, some neurosurgeons, radiologists, and I just like emailed them. I emailed all of them saying that I really, I'd love to help out in your or in like your program or research hospital, wherever it was, like trying to implement this project. And then from there, like some people responded, but one of the people who really, really brought and gave me the opportunity was the person at UHN. So the person at UHN told me that this is the tool they really wanted. They were actually going to hire like another company or like medical experts literally to build this out for them, like another tool. But they're like, why don't we just use your tool instead and help out like, a high school student who's like really passionate about the space. So from there, now I'm working on a research project with them. And the research project is essentially you're trying to find the correlations between brain tumors and the rest of the brain. So with like the brain tumors, for that one, what you need to know first is where exactly the brain tumor is. So if you're trying to find the correlations, where in the brain is the brain tumor? So that's like where the segmentation task comes in for the computer vision. So I already had a 2D segmentation model, as in like 2D MRI scans. But for them, they're working on 3D MRI scans. So currently I'm working on 2 projects for them. So the first one is the 3D segmentation version. So like trying to segment out the 3D brain tumors. And then the other one is like 3D classification. So for those brain tumors, you need to know what grade those brain tumors are. So like how severe is the brain tumor? So there's grades from 1 to 4, I believe. And then grade 4 is like the most severe type. And then grade 1 is like pretty severe, but not as severe as grade 4. So it's like you're trying to classify what grades these brain tumors are. And then with those 2 projects, we'll be finding insights from them. And then we're hoping to put out a research paper as well for that, which is really interesting. So that's what I really see the collaboration going. What I'm trying to be intentional about and expect is like, I want to put as much time as I can. I've already started on it, but mostly during the summers where I'll be committing most of my time to that. So I'm trying to get the real world experience of that, because for my last few projects, I've just been, sitting at home and like programming and building projects like that. But actually working with a team who's doing research in the real world in AI would first of all give me a lot of perspective into what it's like. And then second of all, tell me if like it's something that I really want to pursue, if I really like the building and the research. So those are the main things.
That's really amazing. And talking about this one, this is a really amazing project with a really amazing intention of, identifying brain tumors. And talking about brain tumors, I'll ask you a really noob question, which is that how do these brain tumors actually get formed? Like, how does this happen?
Like with computer vision or like the current process? I can talk about both too.
No, in general, I'm saying in a human body, like these tumors are in a human body, right? So how do these tumors get inside the brain? Like, how do these get formed? Do you have any insights on that?
Like it could be genetic too. It just depends on a bunch of factors. But I've been working mostly on like the diagnosis side, not like how does it form to happen. So when it does form, like how do you diagnose it? Like how do you know where the brain tumor is? How do you know what type of brain tumor it is? And then from there, like because the process for computer vision makes things a lot more efficient, it makes things a lot more accurate. It's also less time consuming because the medical experts have to like manually segment out where the brain tumor is by looking at the scan. So like just by automating that process, I've been looking more on the diagnosis side instead of like, how does this actually come to happen?
Got it. And you also told me that you're working on a research project wherein you are making offshore wind turbines turbines that use 3D and 4D printing.
Yeah.
So tell me more about that. And you also mentioned that it will provide a 7.8x increase in efficiency, reduce costs by over 5 million for each wind turbine. So that is huge. And how does this create the opportunity to repurpose land for other tasks? How does this save land? So all these, talk us into this.
Yeah, for sure. So about a month ago, like my team and I, we started doing this project where we wanted to make a 10x impact. And this was part of the Knowledge Society, like a challenge that we were doing at that time. So in that research project, what I mean by a 10x impact is like, usually what happens in the field is like you have 10%. So it's like you keep iterating on something just to make it a bit more efficient. And then yes, it might compound, but then for 10x, it's like you're just completely blowing it out of the water and doing something different and something that's not really that expected. So for us, what we looked into like different spaces, different problems, and we came across the renewable energy space. So the thing about the renewable energy space is that we've seen so many advancements, especially in like hydro. We've seen it in solar, we've seen it in nuclear. But when looking at the wind energy space, we know that there's such a huge potential with wind turbines, but there are 3 major limitations that are stopping us from implementing wind turbines as our sole source of energy. And those 3 are cost, space, and efficiency. So for the space size of things, one wind turbine requires 1.5 acres of land. So that's basically like the size of 23 tennis courts. So like one wind turbine, same size as 23 tennis courts. Imagine having like 500 wind turbines somewhere. Like that's completely insane. Imagine how many tennis courts you would have at that point. So like paying for all of that space and everything, like that itself is such a cost. And then adding on to that cost, like the initial setup cost for one wind turbine is literally in the millions. It's like $2 to $4 million for one wind turbine. And that wind turbine is relatively small compared to like the ones we were looking at. So that's like just another $1 million spent into wind turbines. And then they're only like 20 to 40% efficient, which is not really a good trade-off, because if you're trying to get a net profit, that takes so much time because of the money you put in. And then after getting all the electricity and converting it into like the money, that's literally not worth it, which is why, especially in developing countries, it's not being implemented. So what we wanted to do is we looked into different solutions and we thought of 4D printing. But the reason why we picked 4D printing is because we wanted to mimic the structure of plant leaf veins. Now, plants have obviously evolved for billions and billions of years. They've become a lot more adaptable. They've become a lot more flexible and more efficient and effective against the wind and other circumstances. So we wanted to mimic that structure for the wind turbine blades. But to make those blades adaptable, we needed to use another manufacturing process because current manufacturing processes can't really support making those blades adaptable. So we decided to propose the method of 4D printing. And if you don't know what 4D printing is, it's essentially allowing a 3D printed object to change its shape or structure depending on external stimulus. So let me give you an example of that. Let's say you had an ice cube, right? That's your 3D object. Now, if you have an external stimulus, in this case, it would be temperature. So this factor would be adding on to the ice cube. And from there, the ice cube would melt, right? Because of the temperature increasing. So because the temperature increases, the ice cube would melt and it would change its shape or structure. So because of that external stimulus, that's what's happening. So that's really what happens to the wind turbine blades, where because of the external stimulus, which in this case would be the wind acting on those blades, it would change its shape or structure to accommodate and make sure that it's the most resistant as it can to be to the load. And that just increases the efficiency by a lot. So that's really what's happening to the wind turbine blades. And that just makes it a lot more efficient. So that was in terms of the space I told you, we'd be saving a lot more space by putting these wind turbines. We're going to put them offshore. So usually wind turbines are on land, right? So the land that could be used for farming and stuff, we could just use it for that purpose. Instead of using the wind turbines, putting them on the land, we'd be putting them into the water and we'd be making them floating wind turbines. Now that already exists. So that's not really the innovation there. It's mostly the blades. So the blades, make it more efficient. We're saving more space. And then the cost also increase. It also reduces by $5 million for each wind turbine. We did some calculations here and there with the initial setup cost and what the return on investment would be. And we got to that number. So those are the three main things: space, cost, and efficiency. We'd be solving these three problems with 4D printing and 3D printing the wind turbines.
Well, this is mind-blowing, Shiza. And what's the update on this? Is this going into the real world? Have you emailed some people to put this into implication? Because saving $5 million on each wind turbine, saving this much space, this is insane. Yeah. So how's the update on this? How are you taking this forward?
Mm-hmm. Yeah. So once we researched, we also reached out to some experts in the field. So we reached out to people who are working at energy companies, people who've already worked with wind turbines, and they validated our idea, saying that it would work and it has a lot of potential because there is growth in that space, because most of the iterations has been on trying to make it more efficient, but it's really not working out. It's just that 10% or 10%. Yeah. And then we wanted to make it 10x. So when we were telling them about the idea, they said that it was a really good idea. All the components would work well together. Currently, right now, we're not looking to pursue this idea, especially with the fact that we do not have that much knowledge into the space of 4D printing and 3D printing, especially because it's still an emerging space. And especially with the engineering knowledge that you need in the background, we thought that especially with 4 people who were working on the project, it would be a bit too much. Obviously, in the future, if we find that we get the engineering knowledge and we're still interested, that'd be another thing. But yeah, that's pretty much it. We got it validated, and yeah, it's a really good idea all in all. So we'll see if we can continue it in the future or not.
Yeah, I get it. And I understand that you have your own limitations, but when you land onto something so big that can have so big an impact, you should really find some way to make this work. Maybe reach out to some amazing people who have the money, or reach out to some important people in the government who can potentially implement it. So if you want my help on this one, I can totally help you with this one. Because if we can create such impact on scale, maybe getting even one state to implement this, that would be great, right? Yeah. So, and I totally understand that on your part. You of course have your own limitation. I mean, you can only you're probably the young Elon Musk. You can't do much right now, so you can't have 5 or 6 world impacting, human impacting companies going at one pace, which is totally fine. But what people like you should be doing is reaching out to people with capital, because that's what you're probably lacking. Because the people who have capital, they'd be more than happy to plunge onto this. Just make sure that you are still in the game with them, make this a partnership with them, get the capital. You have the brains, you have the research, you have the tech. Keep it on your name, but make them get the capital. capital is actually that amplification engine, right?
Yeah.
So if you don't have that, and you can get someone else to do that for you, because something that's even more scarce than capital is brains, and you got that, right? So if you need my help on this one, I can totally help you in reaching out or whatever.
For sure.
Just let me know. All right. Moving on. I'm loving this conversation. So you have written a lot of, or maybe not a lot of, but you have written research papers, and you also have this YouTube series wherein you review and explain research papers, right?
Yeah.
And research papers, to me, I've tried reading some of them, and they are the most nerdiest thing in my view, right? They're so verbose. There's so much of text. I just get bored on the first page itself.
Mm-hmm.
So I want you to tell me that how can now people like me, but don't have the kind of brains that you do, but want to learn something, how can they benefit from a research paper? That's one. And is there a way to get the most out of reading research papers by reading less? Like, is there a TLDR version of a research paper somewhere down? So tell me about this.
Yeah.
How to read research papers.
Mm-hmm.
Yeah.
It makes completely sense that you would read it and you'd be like, I don't want to do this anymore. Like, this is torture. That was literally me a few months ago when like reading research papers. But then I like found that there's like certain techniques that really help. So like in terms of the benefit of research papers, like obviously it like has benefited me so much in terms of just learning about AI, especially like any technical topic, any scientific topic, you can find research papers about and just go down rabbit holes of understanding them. But obviously understanding them is a huge thing too. Like once you do understand them though, like the impact it'll have is like insane, because at least in AI, like in computer vision, the two types of research papers I've confronted is like technical research papers and non-technical research papers. So for technical research papers, it's more like, okay, they explain a certain project that they did and like the steps they took to like go through with that. So that's like the technical part. So obviously they talk about things like loss functions, a bunch of terminology that's thrown around in the computer vision space. And like they'd be just like talking about that, like everybody knows what it is. So obviously like there you'd probably get really lost in terms of understanding. But then there's like those non-technical ones where although like there might be some more jargon, more terminology in the computer vision space, it's like pretty limited, and it does explain what that terminology is. So like there's research papers on how CNNs work, which is like the brains behind the computer vision, like a bunch of other things as well. So that's like more like non-technical. So a really good approach I would say is like you start off with the non-technical, so you get a field of like what research papers are even like, and then once you like read those, then you also increase your knowledge in the computer vision space, and then those terms that they explain in that research paper that's not technical, it can be transferred to the technical research papers, because the technical research papers do touch on the jargon that's used in the non-technical ones. So you'd just be reading through the technical one and it'd be easier to explain like that. But to actually understand it, there's like a certain technique, and I'm so grateful that I found it like as soon as I started research papers, because like you said, like I was just like, this is so torture. Like, how would I understand all these pages of text and like no diagrams? So like it was really confusing for me too. I watched like a few videos and read a few articles on how to really approach research papers. And there's like a TLDR version that's basically the abstract at the top. And then from there, a really good approach is like read the abstract. So you have like a summary of what's really happening. And that's like not that technical either. So that's like pretty good. And then from there, you'd go on to the conclusion. And the conclusion would be telling you about the result of the research paper, or what you're supposed to get out of the research paper based on what the team members who wrote this research paper got. So if you read the abstract, then you read the conclusion, it's kind of like wrapping it around, if that makes sense. Like wrapping around, and then from there, like you'd go through the inside of the research paper depending on what you're interested in. So let's say you wanted to read a research paper on how the CNNs work and you were interested in a certain part. So after reading the abstract and after reading the conclusion, you'd go to the section where it says, how does this part work? And then you'd read through that based on what you're interested in, right? So from there, like if you have that approach, it'd be so much easier to understand. And then you can just scale that up to reading non-technical and technical research papers.
Got it. Thank you so much for sharing that one with me. Now I can go and probably read some research papers and I'll get a little amount of insight into the complex kind of stuff that you people are doing there, right? So great. Thanks for sharing that. All right. And talking about research papers, this one question I wanted to ask you, like if there's someone who's working on a research in some field, maybe, so you don't want to work on something that's already being worked on. You want to build upon something that's already being worked on, right? So if you are doing a research on one thing, but you want to check if there is already existing research but done by someone else on this topic, so how do you do that? How do you find existing research on a specific topic?
I'd say the simple answer is just Google it. Like you'd probably find a lot of articles and videos if there is. Like if it's a really new and like something that hasn't existed before, there's probably going to be some data to back up the fact that your idea might work, your innovation might work. Because like if it's something that's never been implemented, there won't be like a clear research paper or clear article or video just stating how this idea would work. It's like more of you trying to innovate. That's like the innovation part of it. But like if you're looking for existing data, research papers obviously is such a good way. But like even articles, videos, things like that would explain the data behind what your solution is and how it would contribute to it working, giving you validation. For research papers specifically, like if you're trying to build a project and you're looking at different features, I'd recommend like going to just some research paper platforms. So there's like Google Scholar, there's ARZiv. Those are some of them. Papers with Code is a really good one for technical stuff. There's a bunch, honestly. Nature.com, scientific reports. Those are like some of the ones that I use. But yeah, mainly like if you can find data to back up what your innovation is and to prove that it would work with those research papers, with those pieces of content, then it'd work out in your favor.
Absolutely. Thanks again for sharing that one with us. And it is also helpful in not necessarily if you're doing a research, but if you're just writing a blog post, let's say, because I'm into marketing, so I'm talking about that. So when you're writing a blog post, it is always helpful that if you're giving some advice that let's do this, let's maybe make your to-do list this way, that if you're supporting this with some research that's been done, that it is going to help you do the task easier. It is better for your brain to understand that. So that kind of stuff really hits. People trust that okay, there is research and this is legit, right? So it's always helpful to cite research in whatever point you're trying to make, right? Great. All right. So my next question is about being a 15-year-old, right? So, sorry. So I wanted to understand that how were you raised as a kid? Like, were there some specific things that your parents tried to instill into you that got you interested in these things? So are there any specific things that you think that are different about your upbringing than how other kids were brought up? That's one thing. And the other thing is that does your age ever, influence your work ever? Like, do people say, okay, this is just a 15-year-old, I don't need to pay attention, like something like that? Does that ever happen? So, yeah.
Yeah, that's a really good question. I think one thing that my parents have like put into my mind is basically being service oriented into like making an impact. I seriously think that's really what got me into this field. Like without my parents telling me like you need to make a real world impact, because if you're going to leave this world, like you need to impact people. Like money will, I guess it does make some sort of impact, but at the same time, like knowing that you impacted people, like that's like pure joy. And that's something like that has really brought me to this field too. Is like, especially in the medical space, I can impact so many people with the use of computer vision. So like, yeah, from a very young age, like I would always volunteer. I still do like every Friday or like Saturday at my religious community center, like for a couple of hours, just helping out people out. Just that pure joy is that thing that really brings me to volunteering and like service and things like that, making an impact. That's really what drives me to make an impact in the computer vision space. So like just being born with and like growing in terms of, you need to make an impact. You need to help people for that pure joy, that pure happiness. That's really what's guiding me right now, as I mentioned. So from there, like that really got me into the computer vision space, as I mentioned. I think especially getting into the medical space, I started off with like classifying handwritten digits, classifying clothing items, but then, having that sort of sense where it was like, I really want to impact people. That's what really got me to switching the course of where I was going to go with computer vision. And so that's like the question that you asked. In terms of my age, now I would say that it does have a difference for sure. But there's so many ways to get around it. And I've noticed that especially in like the beginning, like not even a few years back, I think it was like when I was 13 or 14, I volunteered for this nonprofit called Barakat Bundle. And what they're doing is they're trying to reduce the rates of maternal mortality. So they're trying to give bundles to mothers and children in India specifically, which has like very high maternal mortality rates. And they're trying to give these mothers like the education and the resources that they need to take care of themselves and their children, especially before and after giving birth. So I just really love their cause. So what I did was like, I went on their website, I went on the contact us page, and I wrote like this huge email about how, even though I'm like 14 or I was 13 at that time, around that age, I really wanted to help them. I really wanted to make an impact in that space. I think if you have that sort of passion and that curiosity and that drive, even if people think like it's just a 15-year-old, how could she even contribute to our team? Like by showing those things and like communicating that, all of that really goes a long way to show that you do have potential and that you would be a valuable asset to their team. So then I like volunteer for Barakat Bundle, and like the people there, like they were like 10 years, 15 years older than me, but honestly, it didn't really matter to me. I don't know if it mattered to them, but to me, like I just tried to do the most I can to make an impact, because that was my intention at the end of the day. So for that, like that was one experience that really shaped my mindset. And like, it doesn't really matter what age I am. I could be 20, I could be 30, I could be doing the same thing that I'm doing right now. It really doesn't matter. Now, obviously there's like some opportunities that require you to be in like university or like undergrad. And I've tried to like go around those too. It's sometimes it works, sometimes it doesn't. But even for UHN, like they did mention that I was their youngest intern that they like ever hired. So even with that, like just define those things and like going against the norm in terms of what people define as success. And like my age is like something that, you know, is a key part of my life, just trying to defy those norms and become unconventional.
All right. Now I feel much better. I feel that age doesn't matter. I'm not old yet. I can still do amazing things, right?
Yeah.
Okay. Great. That's an amazing mindset to keep, that age really doesn't matter. And like you said, there are so many ways to work around it. And although people might mention it and say that, okay, there's a 15-year-old, but they say it as a compliment. And that is because you're doing such amazing things at such an early age. And that shows that you can do really legit things and be taken seriously if you have your work to show, your curiosity to show, your passion to show. Nobody cares about your age. All right. So that's great. My next question is about time management, because being a student in itself is not easy.
Yeah.
And you are also simultaneously a part of the Knowledge Society, simultaneously working on a research project with UHN. And also you are still a team, so you have your friends as well, so you probably have to make time for them as well, maybe go out for playing or stuff. So how do you manage all these things, and how do you manage time around all these things, and what does your typical day look like, if you can give us insight into that?
Yeah, that's a really interesting question. I'm going to be completely honest. I still do struggle with time management with all of these things on my plate. But I think a really good method for me has been the Eisenhower matrix. It's basically a technique that I use. So what I do is like I have daily updates, and obviously I do them every day. That's why they're called daily updates. I basically have a page of my weekly goals, my daily goals, and then my reflection for the day, and then my habit tracker for the day. So if I have my weekly goals in front of me and like I plan those out every week, and then I have my daily goals, which I set based on the weekly goals. So with those daily goals, what I do is like I segment them out in terms of computer vision, segment. I segment them out into like categories that would be, what's urgent right now, what's important right now. And then from there, I would just pick on what I needed to do. So like, let's take an example of this week. Right now, I have like a lot of school culminatings. So that's like a huge thing on my plate. I'm also going to be speaking at like the Microsoft DICE office on Saturday. Like I'm going to be presenting this project that I talked to you about, the Wind Turbine project. I'll be talking about that, and I'll also be on a panel for healthcare, talking about like the future of healthcare and things like that. So those two are the major things that are on my plate. Plus like the research project, I've to make some progress on that with like working with the data for the 3D MRIs. So those three things are my major things right now. So for me, like just planning out each day, especially with Google Calendar, like if you were my friend, you would know how much I love Google Calendar. Like every single thing I time block, even lunch, even dinner, I just time block. And I think that's a really good method to plan out my days and manage my time, especially because of the things that I have on my plate. So like for these three main priorities, like I would just plan them out individually and like how many hours I need to do each day to get to the point that I want. How do I get to that weekly goal? And then I just work my way backwards from that. So that's more like managing my priorities. In terms of like social life, I do have a pretty good social life, I'd say, because like I go to school in person. I hang out with my friends, especially on the weekends. So my social life's pretty good. One thing I would say though is like my sleep schedule is definitely horrible. Like it's completely horrible. I get like 4 to 5 hours of sleep every day, which is not good at all. Definitely wouldn't recommend it. So that's where you get the part where I like struggle with time management and specifically sleep. So I've been working towards that though. It's kind of working out. I'm still trying to like change my cutoff time, as in like when I go to sleep. I think that's like the best way to prevent it. So I've been like working on time management in that aspect specifically, but like my schedule's been working out pretty well in my favor. So yeah, it's going pretty well.
Yeah, right. But we have been talking for about 40 minutes now, and you're saying that we're not friends yet. Why is that?
Oh, sorry. That I didn't mean that. I didn't mean that. Don't worry, we're
No, no worries. I get that I'm 22 and you're 15. I definitely don't fit in your age group, so you've already rejected me as a friend.
Don't worry about
Understand?
it. Don't worry about it. Yeah, you're my friend.
No, everyone is rejecting me based on age. TKS rejected me based on age. You're rejecting me based on age. Okay, get it. Now this is life, okay? And then they say that you're only 22, why do you feel old, right? This is why I feel old, okay? Never mind. And I'm so sorry about coming late to this meeting. Now getting to know that you are a big Google Calendar person, I'm extremely sorry I was late. I was very late for this recording. I absolutely forgot about it. I'm very, very sorry for that. And okay, coming to my next question, which is about the Knowledge Society, right? So how did you get into Knowledge Society? Number one, I did not get managed to. I just did not qualify the eligibility criteria, so that's my bit. But how did you get into the Knowledge Society? And how has your life changed ever since joining the Knowledge Society? Would you be doing the kind of stuff that you're doing right now without joining the Knowledge Society? How much of a difference has it made? Number one. Number two is, how do things operate inside the Knowledge Society? I know how a school operates, but I want to understand how the Knowledge Society operates. Is it like a physical school where you go to every day and there's a teacher teaching and there are some projects? Does it work like that, or is it different?
Yeah, I can explain that. So I heard about TKS, like one of the alumni, her name is Zaina. She like ran this session in my religious community center talking about like these different emerging technologies. And I was just mind blown, like completely mind blown about how much she knew about these emerging technologies. And I was like, well, I want to learn them too. Like, obviously this is so cool to me, just learning about it from her. So, and she was like 16 at that time too. So obviously I was impressed. And she told me she joined TKS, which is the program we're talking about, the Knowledge Society. And from there, like I decided to apply. And the next thing you know, now I'm in TKS, almost done in a few weeks, which is a bit bittersweet. But I've learned so much from TKS, like especially compared to school. Like thinking about if I'd be doing computer vision without TKS, I'm honestly not sure. I feel like I wanted that impact aspect to be there, right? I might have found a trajectory to get to that point, but for sure, TKS helped accelerate the process. Like it really got me into technology in the first place. I might have gotten into it at a later point, but going into TKS, like having that intention of making a real world impact with technology, it just drove me to get into the computer vision space. So honestly, like at this point, if I'm comparing me now with and without TKS, like I'd be a completely different person. Like I wouldn't even be on this podcast right now if it weren't for TKS. So yeah, that's like a major thing it has helped me with, like the knowledge and the skills. Obviously, like another huge part is the community in TKS, like obviously age 13 to 18. So like, sorry about that, the eligibility criteria, but it's such an amazing community. Like the people there, they're so high standard. They're just so amazing to talk to. They're so supportive. Like I've literally never met better people in my life to like interact with. Not the coaches. I mean, technically they're coaches, the founders there, the directors there, all of them, they're like just so friendly, so supportive. And like every day, because of them being surrounded in an environment like that, they're like what pushes me to become the best version of myself. Like that's one of the few things about TKS the many things about TKS that I just really love is the community. It's just such an amazing community to be part of. The opportunities you get, the mentors, all of that is just completely amazing. It's so mind blowing. So the community aspect is another big thing. Sorry, what was your other question? It was like how the TKS sessions run. So obviously, like I'm working on TKS every day because like I just love AI. It's like kind of a part of TKS, although it's like mostly self-learning. So I just kind of consider it part and part. But I just work on it every day, right? So I try to commit as much time as I can. So obviously it's more like self-learning. So as much as you put in, the more you'll get out of it. But there's also sessions every week usually on Saturdays or Sundays, like 3-hour sessions where the directors are teaching us about these different mindsets, these different skills and knowledge, like presentations, boosting your confidence, things like that. So it's not like an everyday school sort of thing where there's a teacher. I wouldn't even call them teachers. They're more like life coaches. They're preparing you in terms of the mindsets, those skills. So that's what I'd consider them as. And from that point on, like having those sessions every week, it really gives you another perspective. And it's literally not like school at all. It's literally the opposite of school. And yet you're getting so much value out of it. So that's usually how the sessions run. And then we have like these research projects that we do. So throughout this year, I've worked with Walmart. That's like what I mentioned in the beginning with the computer vision emerging in that space. So I worked with Walmart like a consulting challenge as part of the Knowledge Society a few months ago. And then I worked on the research project with Wind Turbines, which I also mentioned. So we do like these challenges, these projects in the middle of the years. And we do like hackathons as well, just to expose you to like, how can you actually like come up with these ideas to like implement these sort of things. So from that point on, that's usually what we do in TKS with those sessions, as I mentioned, and then these projects in between the community, all of that is just incredible.
Yeah, I totally get it. And that's amazing how it operates. So basically, it works around the life of a student. That's what I understood from your answer. They're not getting into that much. They're just working around weekends and stuff like that. So, and these sessions are online, or do you have to go to a center or something?
So TKS has like two different programs. So there's like the virtual program, and then there's in-person programs. So specifically in Canada, there's programs in like Vancouver, in Ottawa, and then I'm in the Toronto program. So thankfully I get to go in person. Obviously both the virtual and in-person programs are amazing. But for me, like especially meeting people in TKS in person, learning from the directors in person, like it's just a whole different experience.
Yeah, I can totally understand. And I want such cool friends, but I don't fit into your age criteria. That's the problem,
You're
right?
a cool friend of mine. You're a cool friend of mine.
All right, I'll take that. I need cool friends. Like if any of the TKS fellows want to reach out and talk to me, I'm up for it, right? Be friends with me. Like I'm not too old. Please. All right. And you can reach out to me on Twitter, by the way. I'm at ChoubeySahab. And if you want to reach on email, you'll find the email in show notes. I actually want you to reach out to me because of the kind of cool stuff that you guys are doing. And it actually does not have the kind of visibility that it should. So if I can provide my platform in bringing visibility to the kind of amazing work you people are doing, I would love to. And I would love to talk to you guys so that my brain also opens up a bit. I get to understand where the future is. And maybe in some way I can collaborate with you guys as well in my own capacity. All right. So my last question before the rapid fire starts is that what does the future look like for Shiza Charania?
Interesting question. I've been like contemplating on that for a while now too, especially because as I mentioned, I wanted to be a doctor, but then like it kind of just changed that whole trajectory, especially getting into computer vision and technology. So now I gonna completely change directions. I would still want to be a doctor, but like not as much as I really want to get into AI and computer vision. So I definitely see myself pursuing AI and computer vision in the future. Now, specifically AI, I do see myself pursuing. I'm not 100% sure about computer vision, and I've been like thinking about this a lot too, is like what value could I bring to the computer vision field? Like I've been getting deep into it, but also I kind of like have a visor on my head where I'm focusing on computer vision. So I'm like trying to get in during the summer, get into different subsections. So things like the NLP, like the tech stuff, the reinforcement learning, which is another thing within AI, GANs, which is like generating images and different sort of text and visuals, different sort of content, things like that. Like I just want to get deeper into the AI space and see what's up. And then from there, like it'd be easier for me to decide, like, do I want to get into computer vision or not? And another thing is like, and I told you I wanted to be intentional about this in the summer as well with my internship, is like looking into my internship and like working with the team. I want to see what the real world experience is in terms of AI. Like, is computer vision something I really want to pursue, or do I like the research side more? Do I like the building side more? And then from there, like I can decide like if it's something that I really want to pursue. So from there, like I know that I just want to make an impact, and especially using AI, like I know that there's so many different ways I could get there. So maybe, going through computer vision in the medical space could be an option. It could be something else as well. It's something that I'm currently thinking about though.
Sounds great. And throughout the answer, I love the clarity you have that whatever I do, my main goal will be to create an impact. Mm-hmm. Like that's my main goal. And you found that at such an early age, which is amazing. All right. Now let's move on to the quick rapid fire section. I will give you 2 options and you have to pick one. We'll have 5 of these. All right. Are we good?
Yeah.
Can we start? All right. First one, a beach holiday or a mountain holiday?
Beach holiday.
All right. The next one is that would you read a research paper or go out with friends?
Go out with friends.
That's really cool. Would you read a book or listen to a podcast?
Listen to a podcast.
Mm-hmm. High five. Would you optimize for money versus impact. You've probably already answered this one many times. Yeah, the impact is answered. Okay, so last one puts you in a fix maybe, which is school versus TKS. Which one?
TKS for sure. Every time.
That was surprisingly easy. So I can totally understand the difference between the two. Yeah. That it's a no-brainer that you're choosing TKS over school.
Yeah.
That's what it is. And my regret for not going into TKS and not being able to get into TKS is ever bigger. Okay, never mind. So we are good for this episode. It was so good talking to you, Shiza. And I wasn't expecting to learn so much from this episode, but I did. Oh my Lord, I learned so much. I'm a different person after this episode, just like you're a different person after joining TKS. I could not join TKS, but I can certainly talk to TKS fellows like you, and I can also talk to a lot of your friends, maybe if they want to be friends with me, or if not, I'll just host them, I'll just give them a platform. I'm just good with that much too. Thank you, Shiza, for coming on my podcast. And I believe that I'm probably interviewing a future Elon Musk kind of a person. And this is not the only episode I want to record with you. I want you to come on for sequels. Whenever you do something amazing, just ping me that, okay, I did this amazing thing, this cool thing, and let's talk about it. And I'm already up for it. Okay, just tell me, let me know, and I'll be up for it. And this is the same for all the TKS fellows. So if you're working on something amazing, creating an impact, and you think that people should listen about it, then you are very welcome on my podcast. Shiza, very thank you for coming on the podcast. I would request you to please share any details of how people can connect with you. I believe a lot of founders follow me, a lot of capitalists follow me who are into capital and stuff. So if you can tell them that where they can reach out to you for maybe collaborating with you or just interested in talking about the project that you're working on, what would be the best place for them to reach out?
Usually I would say LinkedIn or Twitter. So my LinkedIn is basically my name. My Twitter is also my name with a capital S and then a capital C, my full name. And then you can also reach me at my email, which is charania.shiza@gmail.com. And yeah, those are pretty much the main ones. Yeah, and thank you so much for inviting me for the podcast. It was really fun talking to you and learn about your perspectives and insights as well.
Okay, that's just generous for you to say that. We all know who was the one actually throwing insights into this episode. But anyway, thank you for doing this, Shiza. I wish you all the best for whatever you work on in the coming years and throughout your life. I hope that you create the maximum amount of impact possible for humanity. Thank you so much for coming on. It was a pleasure hosting you.